Okay, so 6.5 is properties of logarithms. This is related. Wait, logarithms are related to exponentials. So the properties of logarithms are related to the properties of exponents, which was chapter 5. Remember chapter 5? We should know our properties of exponents still. I could give you, this is not on there, I'm just making stuff up right now. I could give you something like x squared multiplied by x to the third. And we have a rule that says when you multiply like bases, what do you do to their exponents? We add the exponents, right? We had another rule in chapter 5 that said if I divide same bases, then we subtract our exponents, right? That was another rule. And then another rule we had in chapter 5 was if we had if we are doing a power to the exponents, then we multiply. Okay, so because logarithms are inverses of exponents, the rules are the same but reversed. But the rules are the same but reversed. So the properties of logarithms are, the first one is the product property that says if I have log base b, so there's no numbers in here, that's what I'm saying, just going over this right here, it's not going to make a lot of sense until we actually use it. But right here we're saying if we have a logarithm of a product, which means we're multiplying some stuff together, we can actually separate that to same base logarithms with each of those factors, the m and the n, but we're going to put addition between. So when it's multiplying, we do addition, which is exactly what we did when it's multiplying the same bases, we did addition, right? Same rules. Over here, if we are dividing what the log is of, the m divided by n, we can separate that into two logarithms with subtraction. And then here, if we have a power, we change it into multiplication. Except for when you multiply a number with a logarithm, you move it to the front so we don't get confused about where that n is. So we move it to the front, and then they have n times, but they didn't write the times symbol, log base b of m. So when it's a power, it actually multiplies. Those are all three same rules I just said. The next section, these examples, I am not going to do exactly what they are doing. I'm just going to use their examples so you can see me do this property a bunch of times. Because these examples, they want us to plug in these numbers and evaluate, and that's going to be a time waster because I'm not going to ask you to actually do that. If I really want the answer for log base 2 of 3/7, I'm going to use my calculator, log base 2 of 3/7. I just want to show you the properties using log base 2 of 3/7, okay? 3/7 has a fraction bar, and fraction bar being division. You were ahead of me. So because it's division, we will use subtraction. We're going to expand. I'm using the word expand. Going to expand this logarithm into two separate logarithms, log base 2 of 3 minus log base 2 of 7. How do you think I knew to put the 3 first? Because it was on top. So that's expanding it out.
But
I'm not going to find an answer. I'm just going to leave it like that. They want us to find an answer. I'm not doing that part, okay? What?
Is the 3 going to be is it going to be raised to, is it log base 2 raised to the 3?
No.
Just 3?
Log never has an exponent on itself. Log is always of a number. And these are good questions. Same questions I was answering yesterday. So don't feel like you can't ask me a question like what he asked me. Sometimes my handwriting's hard to tell too. All right, the next one is log base 2, 21. Now, they gave us 21 because they want us to use either 3 or 7 to expand this. Okay, I could expand it different ways, but we're going to use 3s and 7s to expand it. How do I get 21 from 3s and 7s?
3 and 7.
Right, this is the same thing as log base 2 of 3 times 7, right? So we're going to expand that with what? Addition. log base 2 of 3 plus log base 2 of 7. That's just using the properties. That's all we're doing is we're learning these properties. I don't care what the answer is. Notice how my base was the same every time I expanded it. It's always the same base.
So you're just breaking like the larger number down.
So here's the next one, log base 249.
I think I got this one.
There's actually two different ways to do this one. Jake.
You split it to 2 log base 2 7.
2 log, oh, yeah, that's where I'm going to go, but don't tell me the answer. Tell me how you got there. Because not everybody's as fast as you.
Is square root of 49.
Okay, so you're thinking 49 is the same thing as what? 7 squared. Is that what you were going to do, or are you going to do it a different way?
Yeah, I was going to do 7 squared.
Okay.
Let me put the 2.
Yep. And then from there, we take this 2, we make it into multiplication, so it's 2 log base 2 of 7.
But that just equals 7?
Yep. Because
Oh, because the 2's not a simple log.
you mean the 2's not after log.
Yeah.
Yeah.
But so wouldn't the answer just be 7?
Let me repeat. That's exactly his question.
Oh, it was?
Yeah. So no, if I had log base 2 of 2, I could cancel it because log base 2 of 2 will cancel. But if I just have 2 times this number doesn't cancel. This is just 2 times whatever log base 2 of 7 is, which is not a nice number. Okay, and then this one's a little bit trickier. We can only use 7s or 3s. We can only use 7s or 3s, and we need to create the number 1/3.
Can we just do 1?
Josh, you have an idea?
Make another 3 fraction, like 3 times.
But that's not going to make 1/3.
Well,
I want something equivalent to 1/3. Equivalent. What?
0.33.
First of all, no, it's not equivalent. Second of all, no.
I mean, it's.
Preston, what's your idea?
Would you do 1 times 7? You said something equivalent.
Yes, but I don't think you said what you meant.
I didn't.
He's 1.3.
1/3 times 7 over 7.
Could it just put it like.
No, I don't know what you're saying, but no,
Why do
that's
we
not
have
right.
to use 3 and 7?
Well, because that's what the question says.
Like, can't we just do like?
Okay, never mind.
log
I'm
base
going to
2
tell you if
of
he doesn't have it.
Why can't we just do log base 2 1?
That's what I'm saying. That's
Wait,
what
log
I'm
base
doing.
2 what?
Why can't we just do it like the first problem?
Like log base 2 to the 1.
Oh, yeah, but we can
Minus-
only, it says in it's because of the directions. Okay, we totally can. We totally can do that. We totally can do that. Okay, you guys?
We totally
We
can.
totally can, right up there what he's saying. We totally can have this written as this. Okay, but you can only have 3s and 7s according to the directions. So I'm asking you to think of a way to write 1/3 as a 3 or as a 7. Do you know what I'm talking about now? No! Stop saying decimals.
We should do 7 over 21.
No, because then you have a 21. And I don't want it to be as 21. Oh, okay. Okay.
What about 1/3?
I can't believe you guys didn't come up with that. My fifth bell came up with that.
Why are you saying we're stupid?
No, but I'm recording, so please stop.
I'm just kidding. Guys, she didn't say that. She's a nice
Never did.
person.
All right. So we have log base 2 of 3 to the -1, and where do I put that -1? Okay. That's what I was looking for the whole time, but so some of your other ideas could work. Oops, I forgot to put it in. But this is the one I was looking for just so I could show it to you. Okay, that we could have negative and then that flips it. All right. So that was just some examples with this
Because
these properties.
Oh, do you have to do 5 and 8?
No.
Ooh.
I'm okay. So I didn't say this to you earlier, but I am not going to do all of these notes. I'm going to do picking and choosing certain things that I think are important. And let me pause this one talking for a second.
Welcome back, ladies and gentlemen.
Is x's the same things, only we don't have all numbers. Okay? ln, we have to keep it the same. It's going to be ln the whole time. So when we start expanding this, ln the whole time. Anything that is on the bottom will end up being what operation?
Division.
It is division right now. Anything that's on the bottom will end up being subtraction, right? And anything that's on the top will end up being addition. If there's a power, that'll be multiplication in front, but we're going to expand all of this out. So the first thing that I'm going to do is notice that 5x to the 7th is all being divided by y. So I'm going to pull the 5x to the 7th and the y apart. So my first step is going to be ln 5x to the 7th minus ln y. Right? Because it's the same logarithm.
Did you not just listen to me?
No. So it all has to be ln for this one. I gotta fix this because it's bothering me and probably you too. Okay. Now, ln y is expanded all the way. There's nothing else going on here. But ln 5x to the 7th has stuff going on here. Is the 7 on the 5?
No.
No. So the first thing, or the next thing I'm going to do is separate the 5 and the x to the 7th. So I have ln 5 plus ln x to the 7th minus ln y. So I separated the 5 and the x to the 7th.
Okay, this is kind of easy.
And then the last step is I'm going to move the 7 in front of just the ln x. So ln 5 plus 7 ln x minus ln y.
Final.
And that's final, yes. Using our properties. Next one. What? Whoa, did I go too fast?
Like 3
Okay,
seconds.
so yeah. I don't know what whoa means. Did you get it?
Yeah.
Did you get it? Is he writing it down? You been writing it down, Phil? Good with you? Okay. Now, I haven't done this with you yet. This is new. Condense. So basically the opposite of expand. We're going to take this all the way down to one logarithm.
Basically declining.
Are we just doing the opposite of what we just did?
We're going to do the opposite of what we just did.
Just put it back together.
We're going to put it back together. That's what we're going to do. So when you're done, it will be log of some stuff. But we'll only write log one time when we're done.
I think I got it.
Okay, so when I'm looking here, the first thing that I'm going to do is the opposite of the last thing I did. The last thing I did on that last question was move the 7 in front.
You do the exponent.
So I'm going to do the exponent part first.
So
So my
please
first
do
step,
it.
you can work ahead, but my first step is log 9 plus log of 2 to the 3rd minus log of 3. By the way, what is the base of this log? Just curious.
10.
Okay, it is 10. So now anything that is being added goes on the top of the fraction as multiplication. Anything that's being subtracted ends up on the bottom as division. Adding is on top, subtracting is on the bottom. So I can combine these in multiple steps, or I could actually combine it and be done in one step. I will do it in 2 steps, 2 more steps. But those of you that work faster, you can do it in 1 more step. So my next step, if I do it in one thing at a time, I would do log, and then I would have 9 multiplied by 2 to the 3rd. And then my next step would be log 9 times 2 to the third divided by 3. But since that is all numbers, I am going to find that answer. I'm going to do 9 times 8 divided by 3.
Does that have to be all parentheses?
It does not have to be, but I think it's easier to see what's happening when you put in parentheses.
Wait, what if you
people get confused when I don't. Put it all.
If we put like log and then on top 9 parentheses to the
Write down what you're asking me and I can tell you. Okay, when I multiply 9 times 8 and I divide by 3, 24. That's like the final for condensing that.
Log 24.
Log 24.
Log of 24.
Great, that's fine. That's fine. No, yeah, it's log of 24. That's how you say it. It's the same thing. But, you know, when we say the base with it, we'd say log base 10 of 24. So you can say log of 24.
So
if you just say log 24, that's fine. Sometimes I block people over here. I was trying to move around, but were you able to get it?
Yeah, I got it.
All right, the next one is, oh yeah, I have this in there twice. I don't know why. Next one, expand. If you feel like you have it, you can try this one without me. I'm recording it on a video, so I'm going to talk. But check your answer with it, because number 6 is the most missed kind. Number 6 is always missed by most people. But for number 5, I'm going to expand it. First thing I'm going to do is log base 6 of 3 plus log base 6 of x to the 4th. This 3 and x to the 4th are multiplied, so I expand it with addition. And then from here, log base 6 of 3 plus, I move the 4 in front, 4 log base 6 of x. And then it's expanded. That's it. That one's done. Question? Question? Anybody else? Question? Turn it around. I think it's, Desire, what number are you? 14? 14. Yeah, 10. Okay. Number 6. If it's on the top, it's going to be what?
Addition.
Addition. If it's on the bottom, it's going to be subtraction. So ln 5 minus ln 12x. Right? This is not done though, because 12 times x. So ln 5 minus ln 12 minus ln x. Why did I put a minus ln x?
Because both of them are negative.
Why are both of them negative?
Because they're both on the bottom.
Because both 12 and x are in the bottom.
I know, but
Both of them get minus signs.
they're multiplying that.
They're multiplying together here, but this subtraction sign in front of it says everything after that gets subtracted. So when I break it apart, we're subtracting both of them.
So that's the answer.
This is the answer, yeah. But that's why. Because this subtraction is on 2 things. You just can't tell yet because I hadn't broken them apart. So that's why I was saying earlier, if it's on the bottom, it's going to be negative. It's going to be subtraction. That's one way of making it, not making that silly mistake and saying, oh, well, that's addition. Right here, if it's originally on the bottom, it's going to be subtraction. Okay?
That's it, right?
Good, we're done. All right, condense. So here's 2 condensing practice questions. I see subtraction. Subtraction, when I condense it, turns into division. Should I make a mistake and you guys tell me what I'm
No.
Yes. Yes.
Not yet. We're not ready for that yet.
That's correct. Good job.
We have log
Wait a minute.
x over 9. Maybe he made a mistake. You didn't try it.
No, I'm just thinking about how to solve it.
No. Okay, next one. I'm going to condense. So the first thing I'm going to do is move the exponent of ln 4 plus ln 3 cubed minus ln 12. If it's on the top, it's adding. If it's on the bottom, it's subtracting. So I can actually go straight to the answer if I want to. ln, I've got 4 times 3 cubed on top, and on the bottom I have a 12.
Fine.
And I will simplify that.
To ln 9.
Huh?
ln 9.
And that simplifies to be 9.
So are we done?
For the whole day?
No, with like these notes.
We're always good.
Okay. Questions on this last one before I go? I'm going to scroll it so it's a little higher. Okay. What is next? I think I...
Change the base form.
Yeah, so change of base formula, I did with you guys for like a half second. It's in the next section too. I'm not going to like do a ton of these. I'm just going to show you. If you're asked to do the change of base formula, or if you want to type logarithms into your calculator and don't know how, this is one way of doing it. Change of base formula says, here we have base what?
3.
3. You are allowed to change it into any logarithm base. Any logarithm base you want. That's not a logarithm base. Log, how about base 10? Base 10? Because it's on the calculator? Base 10?
Sure.
Okay, so I'm going to change it into log base 10, and to do that, I take log of the big number 8, and I divide that by log of the little number 3, and I've changed it into log base 10. All you have to do.
That's the whole problem.
Wait, what?
Well, then you type it in your calculator,
Why
find
is
the
the
answer.
last one all of a sudden just-
This is the change of base formula. See, originally the 3 was a little base. Now the 3 is not a little base. So now I'm literally doing log 8 divided by log 3. And I'm going to ask you to type that in your calculator to make sure you know how to type it in your calculator correctly. Don't yell at the answers because I haven't typed it in mine yet.
I have a syntax error.
You want us to write all?
No, I'm just writing them.
I'm going to.
I mean, what else is you like that, right?
I don't know. No, you get that. Because I have a different calculator. Okay. If you didn't get it, you need to ask a question.
Step by step, baby.
You don't have to, but it's something that you can do. And some people have to, like, Brandon's calculator, he doesn't have that log with the little base in the thing. He doesn't have that.
Someone's at your dorm is good one.
Okay, you guys, now I want you to type something else into your calculator. I want you to type in ln 8 divided by ln 3.
Sorry.
Wow, it seems the same number.
Because you can change it to any base you want, as long as you do it on top and the bottom. It's the same answer again. So it doesn't matter if you use log base 10, it doesn't matter if you use ln,
So we can
which
use
is log
E.
base 3.
Should we use E?
This is log. It's not E. This is log base E. You can't do e to the 8th over e to the 3rd. Okay, that is all I'm showing you for this section, but I want to give you something. That's not your assignment. I want to give you something that I know you're going to see in the assignment, and when you try it on your own and I'm not around, you'll like maybe either totally do it wrong or just maybe freak out like, I never saw this before. Can you tell me a different way of writing either of these things?
X to the negative 3, X.
No. No.
Austin.
X to the third.
I think you're saying it right, but you're not saying it right. I think you're envisioning it right, but not saying it. Cube root of x. That is the correct answer there.
What? Why is it X to the negative 3 one?
Because you don't flip the exponent.
Okay, is that X to the negative?
What's another way of writing this one? 1/3 x.
I don't like this. That makes no sense.
What makes no sense?
It doesn't make any sense.
What makes no sense? This that you've been doing since
All of it.
6th grade? Maybe, I don't know when you do this. What do you do X's? 7th grade? Oh, it's not.
Okay, so
I just know that there's stuff on your assignment that has things over 3. And in order to actually do the condensing or expanding, whatever it is, we have to know that this is the same thing as 1/3 multiplied by x. We need to know that fact. So I'm refreshing it because it's on the assignment. Also, if x is 2 over 1/3 power, just like in chapter 5, that is the same thing as the cube root of x. We need to know these to accurately do your assignment. This is prior knowledge that I felt like I needed to bring up again. Okay? All right. That is the end of section 6.5 notes.
Science.
Now let's